Okay, today we are going to be doing the day one of exponential functions. So an exponential function is this form y equals ab to the x, where a is a non-zero constant, so a non-zero whole number, b is greater than 0, not equal to 1, and x is a real number. So all this is really saying is this is the form that we're working with, okay? And A is going to be your y-intercept, and that is also called the starting point. So remember, your y-intercept is where you're crossing the y-axis. So if you're crossing the y-axis, that's where x is 0. Okay, so evaluate each exponential function. And the question we're trying to answer is, how does the value of b, so what's being raised to the power, affect whether it's increasing or decreasing? And then what is the effect of changing x? So we're just going to start by solving y equals 5 to the x for when x is 2, 3, and 4. So I'm going to put my x's here, my y's here, and then I'm going to show my work in the middle here. So my x values are 2, 3, and 4. So if these are my x values, whenever I see x, I'm just going to plug in my x value. So on the first one here, I have 5 squared, so y is 25. And then if x is 3, I'm just going to replace the x with 3. And so 5 to the third is 125. And we're going to do the same thing. Y equals 5 to the fourth. So 5 times 5 times 5 times 5 gives you 625. Okay, over here, so it's asking really the same thing. Domain, remember, means x values. So it's just asking us to evaluate for the x values of -2, 0, and 3. And this is something called function notation. We're still just going to be replacing x. So if my first x value is -2, in those parentheses here, I'm just going to be putting -2. So this notation just means solve for when x is -2. So we're going to go ahead and replace 0.5 to the exponent of -2. Now on here you can use your calculator, but please remember order of operations. You need to do your exponents before you do your multiplication. So in your calculator, you would do 0.5 raised to the second power. And so that would give you 4. Okay, remember, negative exponent does not make the whole number negative. Remember, negative moves it down, so it's still positive. And then 2 times 4 is 8. Okay, and then my next x value is 0. So everywhere I see x, I'm going to put 0. Okay, well, we know that anything raised to the 0 power is 1. So 2 times 1, because we have to do our exponents before we do our multiplication. My last x value is 3. So everywhere I see x, I'm going to put 3. Oh, I'm so sorry about that. So here we're going to do 0.5 raised to the third power, and that will give you 0.125. And then we're going to multiply by 2, and that gives you 0.25. So we have evaluated for these x values. And now we're going to go back to this question up here. How does the value of b affect whether it's increasing or decreasing? So it's asking, as we change x, what is happening to y? And how does that b value affect it? Well, again, remember your b value is what's being raised to the power. So on 1a here, our b value was greater than 1. See, our b value was 5. And as x was increasing, so was y. As my x values were getting bigger, my y values were getting bigger. So when b is greater than 1, my function or my exponential equation is increasing. Now over on 1b over here, my b value is 0.5. That means my b value is less than 1 and my function is decreasing. If we look at as our x values were getting bigger, our y values were getting smaller. So we started with a y value of 8, then we went to 2 and 0.25. So what you should take away from this, I'm so sorry, is that if our b is greater than 1, we're increasing, and if b is less than 1, we're decreasing. And we set up here that b can't be 1, so don't worry about what happens if b is 1, because you won't have a function like that. Okay, so now evaluate the piecewise function for the domain. Again, x values of -1, 4, and 6. So the first thing is, again, this is a piecewise function, so remember pieces of functions. So if my first x value is -1, the first thing I'm going to do is I'm going to look at these inequalities. Well, -1 is less than 3, which means I'm going to use this part right here, the 3x minus 1, because my x value works for that inequality. So for when x is -1, I'm going to have y equals 3x minus 1. Well, if x is -1, then I can just replace x with 1. Do your multiplication first. So -3 minus 1, and your x value is -4. Okay, my next x value is 4. So I'm going to start, my x value is 4. Is 4 less than 3? Nope, that doesn't work. But 4 is greater than or equal to 3. It's greater than. So I'm going to use y equals 2 to the 0.5 raised to the 4th. Since my x is 4, I'm going to do my exponent first. So 0.5 to the 4th power is 0.0625, and then you can multiply, so y equals 0.125. Okay, last one on this problem is when x equals 6. So again, start with these inequalities. Well, is 6 less than 3? 6 is not less than 3, but 6 is greater than or equal to 3. So we're going to use right here y equals 2 to the 0.5x. Well, x is 6. And this is not a very pretty number, warning you ahead of time. But we do our exponent first. So 0.015625, and then multiply by 2. So y is 0.03125. Okay, so that is evaluating for piecewise. So the rest, the big focus on today is really going to be this graphing. Okay, so here we introduce something called an asymptote, and that is a line that continually approaches a given curve but does not meet at any finite distance. And you'll see what this kind of looks like here in just a second. So it might not make sense until we see it. But to graph an exponential function, make a table of values, plot the points. Then we're going to create a curve, and then we'll answer these questions. But first thing is, let's make a table of values. So we're going to make an x column and a y column. And when I make a table of exponential functions, I always use the same x values. I start at -2, and then I go to -1, 0, 1, and 2. So Sorry, my video messed up, but our x values are -2, -1, 0, 1, and 2. And so these are the x values I'm going to use every time I graph an exponential function. So now I want to find the y values. So what we're going to do is we're just going to replace that x where we see x with our x value. Okay, so in your calculator you would do 2 raised to the -2 and then multiply by 3, and that will give you 0.75. And we're just going to continue down, and we're going to keep replacing that x with whatever our x value is. And it's a lot easier to use decimals when you are graphing instead of fractions. Okay, so again, exponents first. Well, this one you don't even need a calculator because we know anything raised to the 0 power is 1. So this 2 to the 0 is 1 times 3 gives you 3. Y equals 3 times 2 to the first power. Well, 2 to the first power is 2 times 3 gives you 6. Y equals 3 times 2 to the second power. Well, 2 to the second power is 4 times 3 gives you 12. Okay, so now that we have these, we can graph. Notice how even though we had negatives up here, okay, remember your negative exponent does not mean that big number is negative. It moves it down. So we have all positive y values here. Okay, so if x is -2, I'm going to go left 2, then I'm going to go up 0.75, so right under 1. X is -1, I'm going to go up 1.5. X is 0, y is 3, x is 1, y is 6, so over 1 to the right, up 6, 2, 3, 4, 5, 6. And then that last one is off our graph, so it would be somewhere like up here. Okay, so notice that this is not a straight line, okay? Our exponential curves look something like this. Now, no matter what x value you put in, we're never going to get a negative because a negative exponent, remember, just makes a fraction. So what's going to happen here is we're going to get closer and closer and closer and closer to 0, but it's never going to touch 0. So since I'm never crossing that y-axis, on our y-axis is where we have something called an asymptote. And I'm going to draw it in with a dotted line. So for this unit, okay, all of our asymptotes will be this horizontal line on your x-axis. Now, remember horizontal lines. If you have a horizontal line, I have no idea what just happened to my pencil. Okay, if you have a horizontal line, your y value is never changing. So the equation for this line is y equals 0. So the asymptote is y equals 0. And again, for every exponential this unit, your asymptote will be y equals 0. Okay? All right, so up here we had some other questions, domain and range. So domain is your x values. Well, if we look at our x values from left to right on our curve, we're going to cover every single x value eventually. So our domain is -infinity to +infinity. Remember, for infinity signs, we use parentheses. Our range is our y value, so we look from bottom to top of our graph. Well, we have nothing down here, and remember our curve is going to get closer and closer to 0. But since it's never touching 0, I'm going to put a parenthesis 0. And then bottom to top, on the top, it's going to all infinity y values. Okay, so that's your domain and range. We just have the y-intercept. So the y-intercept, hopefully you can see, is right there at 0, 3. Now, if you look back on that first page, notice how we said A is the y-intercept. So we actually get the y-intercept from the number that's not being raised to the x. Okay, and then what happens as x increases? Well, since b is greater than 1, our exponential is increasing. Okay, so next we have the average rate of change. Well, remember, average rate of change is the change in y over change in x. And we want to find the average rate of change for the function over this interval. Now, when we have an average rate of change interval, these are x values. This is what confuses people the most. But when it gives you an average rate of change interval, it is giving you x values. So when I have a problem like this, I'm going to make a baby table. I'm going to put some x values and some y values. Well, right now all I know is my x values, right? Because that's what it gave us. Well, if we look at our big table up here, we know when x is -2, y is 0.75. When x is 1, y is 6. So if I want to find the average rate of change, that's change in y over change in x. So it's just like we did when we had all of our slope problems. I'm going to take my y value, so 6 minus 0.75, that goes on my numerator. And then I'm going to put over my x values. Well, since I started with the bottom number for y, I'm going to start with the bottom number for x. So 1 minus -2. So that's going to be 5.25 over 1 minus -2. That's going to give you 3. Okay, so 5.25 divided by 3 gives you 1.75. So that is your average rate of change for that. Okay, so we're going to be doing the same thing that we did up here. We're going to start by making a table. My x values, -2, -1, 0, 1, and 2. And again, you really want to have a calculator here, because what's going to be easiest is if you plug this into your calculator. Make sure you're using parentheses on your fraction. Okay, so do your exponent first and then multiply. I want you to pause the video and try to fill in your table. So I'm going to go ahead and fill this in because I know this video is getting long. Okay, so next I'm going to plot my points. -2, 8, -1, 4, 0, 2, 1, 1, and then 2, 0.5. Now remember, no matter what exponent you put in there, even if it's negative, you're still going to get a positive answer. So our curve is just going to get closer and closer to 0, which means our asymptote is again y equals 0. We're getting closer and closer and closer to that x-axis. My domain, the x values, I'm going to cover every single x value because this is going to keep going. Like, obviously it's not going to look like that, but hopefully you get the point. My range, my y values from bottom to top, I'm getting closer and closer to 0 at the bottom, but I'm never touching 0, so don't use a bracket, use a parenthesis, and then we're going all the way to positive infinity. So that is our domain and range. And then the last thing we have is our y-intercept. And again, our a value tells us our y-intercept, but we can also see it on our graph here is 0, 2. Okay, average rate of change, these are our x values. So I'm going to make a baby table. My x value is 1 and 2. Well, if I look at my big table, I already have those values. So 0.5 my change in y over my change in x. Since I started with the bottom y, I'm going to start with the bottom x. So -3.5 over +3. Use your calculator and hopefully you get -1.167, and I rounded. So that is your average rate of change. Okay, I'm going to go over this really quickly, comparing the properties of this equation with this graph. Well, a couple things we notice about this graph is that it's increasing. As x increases, so does y. So the graph is increasing, and then the y-intercept is at 0, 1. Well, up here, my y-intercept, my a value is 2. So when x is 0, y is 2. My b is 3. That's greater than 1, which means it's also increasing. So they're both increasing. But they have different y-intercepts. And of course they would have the same asymptote of y equals 0. Okay, very last question, comparing the functions y equals 2x and y equals to the x with a table to figure out which one increases faster. So for this, I'm going to go ahead and use 0, 1, 2, 3, 4, and 5. I think it'll be easier for us to see what happens here. And then 0, 1, 2, 3, 4, and 5. I want you to pause the video and try and fill out your y values. Okay, hopefully you paused it and you weren't just waiting for me to do it, but if we have y equals 2x, I'm just going to replace x with my x value. So first we have 2 times 0, that gives us 0, 2 times 1, 2 times 2, 2 times 3, 2 times 4, and then 2 times 10. And then over here, we would have 2 to the x, so raised to that power. Well, 2 to the 0 power is of course going to give us 1, right? Everything to the 0 power gives us 1. 2 to the first power, so 2 once gives us 2. 2 to the second power, 2 times 2 is 4. 2 to the third power, 2 times 2 times 2. And we're just going to keep multiplying by 2 each time. Okay, so hopefully you can see if you look over at this table, we have the same x values, right? But we only get up to a y value of 10. Over here we get up to a y value of 32. So my exponential function is definitely increasing faster than my linear function.